Welcome to School of Chemistry. Today we'll be looking at the concept of alkane series. The alkanes are aliphatic hydrocarbons that form a homologous series of saturated hydrocarbons, which can be represented by the general formula CnH2n plus 2. In each alkane member, all the carbon atoms are tetrahedrally bonded to hydrogen and other carbon atoms. That means the 4 valence electrons in the electronic configuration of carbon are all used in bonding. And since all these valence electrons are all used, that is why hydrocarbons are very, very stable. The alkanes are very, very stable. Let's look at the structural formula of some alkanes. One, we have methane, CH4. That means carbon is bonded to 4 hydrogen atoms with single bonds. As you can see, this is the structural formula for methane, CH4. The second member is ethane. Ethane has 2 carbons bonded to 6 hydrogen atoms. That is, ethane is C2H6. So these are the 2 carbon atoms bonded by single bond to hydrogen atom, 6 hydrogen atoms. You can see that each carbon has only 4 bonds, nothing less, nothing more. This is ethane. The tetravalency of carbon is always maintained. We have propane, which is C3H8. It has 3 carbons, 8 hydrogen. Each carbon is having 4 bonds. And since all the 4 valence of electrons of each carbon atom in an alkane molecule are used up, the alkanes are always very stable compounds, as you can see in this propane. All of them having a carbon-carbon single bond and a carbon-hydrogen bond. This propane. We have butane that has 4 carbons and bonded to 4 carbons bonded to 10 hydrogen atoms. You can see, you can count. We have 4, 1, 2, 3, 4 atoms, and the tetravalency of carbon is being maintained. That is, carbon having 4 bonds to hydrogen atoms and other carbon atom. Like the first carbon has 1, 2, 3. It's bonded to 3 hydrogen and 1 bond to 1 carbon. That is the 4 bond. The tetravalency of carbon must always be maintained. This is butane, C4H10. So anytime you're writing the structure in organic compound, make sure the tetravalency is maintained. Let's study the simplest of the alkanes, methane. Methane is the simplest compound in the alkane series with the molecular formula CH4. Besides being a component of petroleum gas, it is the major constituent of natural gas, which issues from the ground in great quantities in certain parts of the world. Methane is produced during the decomposition of plants matter in the absence of air. It is given off from swamps, and it is often known as marsh gas. Let's look at the laboratory preparation of methane. Methane is usually prepared by heating anhydrous sodium ethanoate with an alkali, usually soda lime or quicklime, to yield sodium carbonate, and methane is given up. So it's a reaction between sodium ethanoate and sodium hydroxide to yield sodium carbonate and methane. Let's look at the physical properties of methane. 1. It is a colorless and odorless gas. It is only slightly soluble in water. It is less dense than air. It has no action on litmus. Chemical properties. Combustion. Now, general equation for the combustion of alkane is CXHY, where X is the number of carbon atom and Y is the number of hydrogen, bracket X plus Y over 4 O2, Y over 2 H2O plus XCO2. Example, methane burns in air to yield carbon 4 oxide and water. So CH4 plus 2O2 to give you 2H2O plus CO2. If you follow that formula, you see that the methane, the X is 1, so carbon CO2 will carry 1. Now Y is 4. Y over 2 is going to be what? 2. This is why you're having 2 water. Now, if you put that formula, X plus Y over 4 together, you have 2 in front of oxygen. That is how to balance the combustion of alkanes. Chlorination. Methyl undergoes substitution with chlorine to give a mixture of products. Substitution reaction is actually the replacement of an atom or a group of atom by another atom. In this case, is chlorine replacing hydrogen. First, if chlorine reacts with methane, to substitute one hydrogen atom, and you have chloromethane. If chloromethane reacts with chlorine, a second hydrogen atom will be replaced, and you're going to have dichloromethane. If dichloromethane reacts with chlorine, a third hydrogen atom will be replaced, and you will have trichloromethane. If trichloromethane reacts with chlorine, the fourth hydrogen atom will be replaced, and you have tetrachloromethane. So that is it about the chemistry of methane. If it's your first time on this channel, do not forget to subscribe, share, like, and comment. Thank you.